Good morning, guys. Welcome to Bar Z. My name's Stan, and here we are with our old pal, the Ridgid 535, which is the cousin to the standard Ridgid 500. But 535 is a good machine. We bought this machine brand new in 1981, and God, what a workhorse! We've done some upgrades to it. I've added a foot switch. This thing did not originally come with a foot switch. Ridgid sent out a recall. I didn't answer it. They sent out a recall in the early 90s and said, hey, you need to have a foot switch for safety. Send us your machine and we'll give you a free foot switch. Or go to your nearest service center. I didn't do it, so I had to put it in myself. A couple $100, and that's a genuine Ridgid foot switch. And it works well. It's got a real heavy duty snap switch in the foot pedal. But that's not the reason for this video today. The reason I put the foot switch on is because I'm creating an accessory for it and finding another use for this thing and using it kind of as a power takeoff. 1-inch shaft, flats cut in at 120 degrees apart, so it'll clamp down on a 3-jaw. This is kind of a loose variation of the Jacobs or Sorgen type chuck. And then out at the end we've got a chain coupling, and these are cool because I don't know whether you can see that misalignment. They're very forgiving and they transfer a boatload of torque. And there's another thing too, you buy everything separately, drive, driven, and the chain. You buy all that separately, and as long as you get the same series of coupling, that's 1 inch. That's 7/8. So you can make an adapter, and they're available in metric. So if you got an American or an Imperial type motor going up against a European pump or something, you can mix and match and get these chain couplings to transfer the power. They're a little noisy. They got a 5,000 RPM limit, and they're good for misalignments on angularity, as you can see here, and parallelism both. So you can be out on 2 different axes, and they're very forgiving. So I love a chain coupling. They do have a kind of a urethane cover that you can buy, not mandatory, but it'll enclose this. And then at that point you can pack it with grease and put the enclosure around it, and it'll pack this whole thing in and contain it and help contain the grease and keep contaminants out. So that is an option for these. These are all McMaster car. Now what I've done here, I've cut a key slot in this shaft, and I went and TIG welded it in. I tacked it in front and back so the key doesn't get lost, because this is where this accessory is going to bolt on. And then down here we took a piece of 2x, I think that's 2x4. Yeah, it's 2x4 rectangular tubing, and we welded in some bosses in there. So there's some threaded bosses in there that bolt up to the factory bolts on the machine, so I didn't have to actually modify the machine, which is what I was trying to avoid. And then we lobbed off the corners, welded up the bosses, and then after the bosses were welded, those threaded bosses go all the way through. Then after that we just made some end caps and welded them on, polished ground, and painted. So we've got a mount, and we've got a shaft, and we've got a coupling. God, what does this hook up to? And any of you know that have ever run a pipe machine, this has got gobs of torque and not a high speed. So exactly what we want. Let's go see what we're hooking this thing up to. Okay, well, I picked this up from James Green years ago. This is a Peckstone Wilcox crimping machine. It's taken apart right now, but it's for crimping sheet metal. And these dies are replaceable. There's a gland nut out here on the end, and this die and this space are removable. I'm going to show you the shaft in a second. And but we came out here and we actually modified the input shaft. This is a 7/8 shaft. Remember, my drive shaft is 1 inch, so we adapted it. There's 1 inch here, 7/8 here, and all we did is cut a keyway in there, and we could drop our coupling on, and that's for our misalignment. And the thing is, we've got a swivel here that clamps, and then it's kind of a bench clamp here that clamps onto that yellow piece that I showed you down on the pipe threader. So this thing gets removed and installed frequently. So we don't want to have to hassle with a shaft alignment every single time we want to take it on and off the machine. Did a couple other things. When I got into this thing, I started looking at it. The whole thing's put together with pins. These are all straight pins. So there's a pin there, and then see there's another pin in here. That's a drive gear there. But what I did here, I just didn't trust a pin to transfer that kind of torque. So you can see way down in there, you can see I put a key in there too. So I took this is the drive gear. So I took the drive gear and broached it out, and then cut a corresponding key into the shaft. So we've got a positive way to drive it, and I've still got the pin in there just to retain it. Okay, which is no fun to get inside this housing, but I got it in. So this is the drive gear, and then the other one goes right above this. There's another shaft right above this. It sticks out up here, and that's the driven gear. So let's go take a look at that. I've got that shaft out, and it presented us with some unique challenges, and which is actually keyway timing. Here I've got the driven gear on the other shaft. This is what the shaft looks like on that upper part, and I've got the pin out, and I've got a pin punch through it, and you can see there I've already got a key broached in it. But how do we machine? The big thing is how do we machine the groove or the keyway in the shaft and keep the pin timed at the same time? How do we measure that? What do we do? So I'm gonna show you what I did, and it's down and dirty. And see, that keyway is in no way, it's just randomly done, eyeball 90 degrees. I guess I could have done a bunch of measuring and figured that out, but I didn't feel like it. But it's just eyeball centric, 90 degrees. But let me show you how we're gonna measure the shaft and get the keyway set and get it so the pin can go in properly. How would you do that? Let's think about that. Okay, well, here's the answer for how we're going to center up on that shaft. We need to simulate that key. What I made, I keep dropping it, is a half a key. I just stuck it on the belt sander real quick and cut half of the key down. And I made it a little tapered. And all we're going to do is slip it in the half a keyway that we already have, as so, and then we're going to come in and touch with an edge finder. We're going to come in and touch this side of it and this side of it with everything sticking out of the vise. We're going to clamp everything in the vise with a pin in it. The pin's got to be in it, so we're going to put the pin in it, my half a key in there, center, on the DRO, and find center of that pin. And at that point, we're going to pull this pin out, pull the gear off, and cut our keyway. That way we know our keyway's in the correct place. So that was my way of doing it. I'm sure there's other ways to do it, a lot more technical, a lot more involved, but that was down and dirty. And actually, this idea came from a neighbor. His name's Brett. He's also a machinist for many years. And Brett came up with that idea, and I used it, and I loved it. So thank you, Brett. And we're just going to go get this set up on the milling machine, get the key cut in there so we can transfer power without really worrying about shearing off those pins. That was kind of my worry. They didn't broach that easily. I did do a hardness check, and these things are high 40s, they're 48, 49 hardness, so right at 50. So they're reasonably hard, and they didn't broach that easily, but they are machinable, the gears I'm talking about. And so I don't worry about them blowing apart, but those little keys, I do worry about a little 1/8" key shearing off. So I think between the key and the pin, I think we're good to transfer some power. This was an old rotary hand machine which had a gear reduction. So with the gear reduction, you're able to multiply your hand force and things like that. But that Ridgid pipe machine sure throws puts out a lot of torque. I mean, that thing, if you just put a pipe wrench on a pipe and chuck it up, it'll twist a piece of pipe in half. How's that? So it's pretty unforgiving, and I'm trying to find the weak links in this little fellow right here, this Pexto and Wilcox drive. All right, so let's get this machined, get this thing back together, and I'm sure you guys want to see this thing work. Okay, so we got our shaft in the milling vise with a couple of V-blocks, and we're going to tap those down at the last bit. And I'm still not completely tightened up. I'm using my pin to just kind of clock it around until I see parallel with that scale. I got a scale laying on there right at 3 inches, right on top of the key. And I'm just going eyeball right down the top of the milling vise to get this thing, the key, top dead center, if you will. I don't know any other way to get this truly top dead center, so I'm pretty happy there. I'm going to go ahead and snug up the vise. I'm going to grab a hammer and tap down those 2 little V-blocks. Make sure they're completely seated. And give it a final cinch. And now we are tight. And I'm just using my my pin punch. Now, next thing we're going to do, we're going to leave the pin punch in. And remember, we got our little sleeve here, our little half key that we're using to measure from. And I'm just going to come in with a wiggler right there and come in and touch, zero it up, get in the center of the actual key. Then I can remove all this. I let it hang out of the vise so I can pull all this out. And I can get in there. I'll mark my limits with a felt pen so I know how far to cut the keyway. And now we've timed our key to our pin, to an existing pin that was already there. So we just had to make it work with whatever's in there. There's a little slop on there. You know, those pin holes are a little wallowed out. You know, this thing's really old. I think it's like a 50s model Pexto. All right. So let me get a wiggler in there, and we'll grab each side of that. Okay, so we're all set up with a wiggler, and you know, it's a 3/8 Mitutoyo wiggler, kind of a little bullnose thing. And you know, if you get mills and stuff that are the same size shank, this is the right size for the key and the keyway, but it's got a 3/8 shank. So gotta love it. I always pick that whenever I can, because you know, it's the little things like changing collets that are worrisome. This is a little 4-flute by Niagara cutter. Great little milling cutter, tin coated. All right, so let's find center of this thing. We're going to use the center function on our DRO. I'm spinning about 800 RPM. Alright, so we got a 0, and we're going to come back and make sure it repeats. And we do. We'll come over to this side of the key and repeat that process. Sideways, 382, do it again. The rotational force is trying to push our key out. .382, same number. All right, so now we're going to split that number in the DRO. You can't see what I'm doing. But at this point, we're going to come into 0 after we split our number. And that puts us on center of that key. We're going to unlock the table and change out our milling cutter. And we can pull all this malarkey out of here. What I do want to do though first, I want to make a limit line for my I want to make a limit line for my cuts. So I'm just gonna go get it back in that keyhole right there. And we're just gonna put a little scribe line right there so I can see where that key needs to end. Oh yeah, okay. And then the other end is right up against that shoulder. Simple. Now what I've always been taught to do is you bring a milling cutter down, and you know when you do that, you got the flat bottom of the mill against a curved surface, and to base your depth of cut for a key, you want half the key. Only after you've established a full pattern on the shaft, because you're on a curved surface, the mill's flat, so you're only going to touch in one spot at first, and then the cut's going to widen as you go. When you see full contact, when you see full width of the cutter all the way out to the outer edge, from there on the shaft, you start your counting, and that's where you make your measurement from there, from the outer edge. And I've always had them fit within a couple thousandths doing that. Okay, we've got a 3/16 key. We want half of that. That's 93.5 thousandths. So we've already set our 0 to our full diameter of our cut. So let's get some of this plunge milling or ramp milling in. We're going to go back down to our 0 point. And I'm just going to hit the feed, start coming over and start coming down. And we'll start by taking out 10 thousandths. And do a little bit more of a plunge. That felt good. Let's go down to 30. Watch your ears, here comes the blower. I'm going to go ahead and take it over that shoulder now and make a note of that number. Yep. 1.175. We're at 60 thousandths depth. I'm going to go to 80. Going to 90. And back down to our 93.5. And back to our 0. Okay. Okay, all that's left to do now is actually make a key. We've got rounded edges, so you cut a key a little bit oversized, take it to the belt sounder around the corners, and drop it in, and then it's captured in there after it's installed. It can't slip out like you had like the ones with a solid key. So we want it to be captured in there. We don't want it to slide out. So let's go make a key. Okay, this is a 3/16 by 3/16. It's called Make a Key. This is available in plus sizes too. So this is actually a plus size. So I'm just gonna put a little mark there, and just go over the portaband and cut that little fella right there at that little green mark, and then shape the ends. You know, you saw when I laid it down there, I just put it past the edge of my hole slightly. All right. So let me go cut that and round it off, and we'll check our first fit. Okay, we got our key done, and we just took it over to the belt sander and, you know, rounded the corners and try to match the radius. You don't have to get too picky with it. You don't have to use radius gauges and stuff like that. Just do it by eye. You want it to just drop into your groove, and it's okay to have a little bit of slop. And like I said before, this is oversized key stock. Now, 3/16 is 1875. This stuff comes in about 190, so it's only a few thousandths over. So a little bit of time on the plate over by the sink with a little bit of sandpaper, and you can polish it down and get it right where you want it. Now, and I use the oversized stock for repairs on existing keys that have maybe hammered out a little bit. The oversized stock is pretty good. So this one, I got this one filed so it fits pretty darn tight. And we're going to get started on our key there. And she goes on pretty nice. And we're going to find our punch here and try to line up a hole. And see how our punch goes through. See if we still line up. That would be good, right? I need to come this way. All right. Yeah, don't get carried away with it. There's our punch going through. Yeah, don't get too keen on it. You know, it took me three or four trips back to the belt sander. This is not the first fit up, so it takes a little bit of time to get them fitted and where you're happy with it. But we've got the keyway and the pin timed, even though we don't even know the position of the key. It was just eyeball centric, 90 degrees, but we made it all land together. And that's how you do it. We drive the pin in, and now we can finish our putting our pexto back together. Okay, so let's put this pig back together. We've got the shaft. I just coated the shaft with a little bit of grease. Steel shaft running in cast iron, no bushings or anything like that. Maybe if I love this contraption later on, I'll give it some love and give it some bronze bushings, just some plain bearings. So we're gonna assemble our shaft with our key, and now we can't possibly get the pin 180 out, so that's good, right? But we need to get that key in there, so we need to stick that over there. We're going to drop in our key right here, and then start bringing our gear in. Then that dude can go there, so we can clock this, rotate our gear until we've got good alignment on the pin. And our pin lead-in edge looks good. It's tapered. So we should start just fine. Yep. And I feel it going in right on the other side. So between the pin and that key, we're pretty confident that everything's going to run right and not shear off. You know, that key's going to take the brunt of the load as far as as you know, torsional load. That the pin's just to maintain alignment, but the key takes the rotational force. We've got another thrust collar to put on out here, which goes on the same way. It's just a collar and a pin, and stops it from doing that. And then this thing's ready to go back on. Okay, we're back to handheld, and we've got the unit put back together, and we've got our chain coupling put back on, and there's the key for the drive of the main shaft. Originally, this thing had a large gear here, and a smaller gear here, and there was a crank handle up here. So that was your torque multiplier for a hand crank. And it was missing some parts. I was actually missing this second gear here. So we're going straight into this lower with the we've turned the we've turned the driven into the drive, and we turned the drive into the driven gear within here. But both of these countershafts have keys now, keys and pins. We've got the thrust collars installed. There's our two thrust collars. Here's our these are the actual crimping dies. And the thing about these is they have to be timed to the gears in the back as well, because they're almost like a gear themselves, and they have to mate up there. This creates downward pressure here. When I release this, you'll see these guys start to spread apart, and they're on a kind of a spring-loaded leaf spring inside to spread them out when you release that screw. So we're going to go put it over on the pipe threader. But that is a crimping setup for an old Pexto. And there's a swivel head here. This is round inside, so this thing can swivel on the head. It's got a kind of a gooseneck, and then down here there's a clamp to clamp it up on a table. But that's what's going to clamp up on that yellow bar that I built. All right, let's go get it installed and test it. If we like it, maybe we'll clean this thing up, give it a spit bath, and give it a coat of paint. Okay, so we got everything installed. It took about, I don't know, 5 minutes. It's not a huge deal to put this on. And the Pexto, the table clamp, just clamps to that piece of tubing right there that's bolted to the machine. And then we've got the swivel down here with that set screw. And like I say, with the chain coupling, it's not that picky on how you install it. You know, you can see it's a little movement there. I can wiggle that shaft around, and it doesn't really care, you know, if you're out of alignment a little bit. That this chain coupling is pretty forgiving, so you can install it, and you know, you don't have to sit there and do a shaft alignment every time. So it's all set. We're chucked up. Got my foot pedal down here, so we can let's go get a piece of sheet metal and run it through. Okay, so we're all set up. I've got a piece of 18 gauge galv here with it's a shear cut, but you can pretend this is a curved piece of ductwork, and we're gonna get it started in there and just kind of steer it on its way through. And this is what you're left with, is a crimped end of a duct. And what that does is that diminishes that side of the duct so it fits inside of another one like a stovepipe. All right, so pretty handy tool, and you know, it's going to help doing duct work. But you know, we can pull the glands out, change out these crimping dies, and put in maybe some bead dies. So we could actually have a crimp here with a bead below it and get some nice results. Or maybe we could do a combination. You know, we can play with these spacers and play with the crimping dies, and maybe come up where we do the crimp and the bead all at the same time. That might be pushing it, I don't know, but we'll play around with it. But you know, the crimping dies are the important ones, because they have to be timed to the gear set inside the unit. A set of beading dies just has a male and female die, and they don't really care if they're timed at all. It's just a round part, doesn't have any teeth. All right, well, you know, I hope you enjoyed what we did here. You know, this is a versatile machine, and I've found a couple of uses for it outside of just thread and pipe. I think I'm happy enough with it. We can give this a spit bath and give that Pexto a coat of paint, and you know, take it out on a job site. We'll take this thing, it'll actually store right down in the cabinet underneath. So pretty handy. All right, you guys, thanks for tuning in. Thanks for watching me use a tool for what it's not intended to be used for.